So today we'll be doing section 5.3, solving systems of equations using elimination. So if you remember, a systems of equations are two lines, and the solution is where the two of them intersect, if they do intersect. So far we've done it doing graphing, and we've done it with substitution. So today we're going to try this with elimination. Personally, this is my favorite way to solve equations. Alright, we'll do monitoring progress 1 on page 249. Now what's key here is to line up your equations. So, with substitution, we have to isolate a variable. With elimination, you want to line up your variables. And here's what your goal is. Your goal is to eliminate one of the variables when you add them to make it 0. So let's just look at these two equations. The x's or the y's. If I add one of them, will they be 0? Yeah. Which one? The x's. So when I add them, these don't cancel out, but when you add them, they make 0. Let's add these two. 6y equals 12, y equals 2. So remember, we're looking for a point. And I already got 2. So how do I find x? Plug it in. Which one do I plug it into? Whichever tickles or giggles you. So, let's try the first one. 3x plus 2 times 2 equals 7. 3x plus 4 equals 7. 3x equals 3. X equals 1. And there's my solution. Okay, so now there's going to be instances where it's not as easy. When you look at the two variables, if I add them, there's not one that I can automatically eliminate. However, we can kind of force it to become 0 by using the multiplication property. I'm going to multiply something to both sides of the equation to make it able to eliminate. Okay, so let's look at it. Which one do we want to eliminate, the x's or the y's? X's. Let's do the x's. Okay, so that means that first equation, what should that x be? 3x. Negative 3x. Right? Because negative 3 and positive 3. So we're going to multiply this entire puppy by negative 3. So let's rewrite it. Negative 3x plus 9y equals negative 72. Now I'm not going to rewrite the second one. I don't need to. Okay, which variables make 0? The x's. Good. This one becomes 10y equals negative 60. Good. Y equals? Awesome. Okay. Now go back to the original equation. Which one do you want to use, the first or the second? Which one? Which tickles and giggles you? The second one. That one tickles and giggles me. So for y, I'm going to put in negative 6. 3x minus 6 equals 12. 3x equals 18. X equals 6. There you go. Okay, so I skipped to number 18 from the textbook on page 251. I'm going to look at these two equations and I'm going to think, is there a variable that I could easily add to make 0? No. Now, is there a number that I can multiply one of the equations by, both sides, so that it makes 0? No. So that means that I have to multiply both equations. So the smallest number you pick would probably be easiest. So what would be the greatest? No, the least common multiple, and for which 1. Alden.
Well, both of them you had to get 24.
Good.
So then, well, that's the top equation you multiply by 2.
Perfect.
Bottom equation.
Okay, so he said that 24 for the x. The top one we're going to multiply by 2. The bottom one, what are we going to multiply that by? Not 3, by -3. Because one has to be positive and one has to be negative. So now we're going to rewrite both of them. Here's the first one. First one's going to be 24x minus y equals -4. Second equation. -24x minus 33y equals -90. Okay. I can now eliminate the x's. This comes out to be -47y equals -94. Y equals 2. Good job. Okay. Which equation do you want to plug in? First or second? Sure, let's do the second one for y now. 8x plus 11 times 2 equals 30. 8x plus 22 equals 30. 8x equals 8. X equals 1. There's your answer.